All right. For those of you who haven't scanned the QR code, please do the attendance check. You all know how to do it, right? So I don't have the print out. Just do this and I will check your name online. Okay, sad story. Last time I uploaded the video and I saw average people watch it for less than 10 minutes. So did you learn anything from the last video? I uploaded 45 minutes video, but most of you watch it less than 10 minutes. This is the first time yeah. I'm good. Okay. Okay, so last time we talked about how we find the research gap. Okay, and I think that's the most important part of your research journey. You have to find the gap that you want to pursue. And the most important is to know why, right? And I encourage you to practice when talking to your friends and to your family, telling them why you do it, why is it important, not what you actually do, right? They don't know, they are from different fields, right? So it's better to communicate with your people why you want to do it. And by understand the why, it will help you to be able to come up with a better research questions. And last time we talked about the identifying the gap, come up with a research question, but this time we're going to talk about what's next in terms of development of your proposal. And I believe most of you are master students, right? Any PhD? Okay, so after that, after you get your questions, after you talk to people, right? Talk to people about your ideas, getting that feedback. The next step would be to form your proposal, and which will include a few different things. There are various ways to do this, but I would like to give you the example of what we use at our department. So research. Okay, this is added all of the research proposal. The research proposal should exist to clearly justify why problem matters, what gap remain, and how the proposed study will address it in the rigorous and feasible way. Okay, and this is the structure of the research proposal at chemical engineering. So this is the structure, right? We start with the title, the 200 word, 300 word abstract, introduction, objective, scope, literature review, and then the method. And of course, we can go one by one, but for me, the way I approach this is a little bit different. So I would normally start with the introduction because we already identified the gap. We know the why. Introduction is like a storytelling of the overall problem that you want to solve and then you approach, right? So introduction should be number one thing you do. And then next would be the objective. Objective, what is objective? Objective is normally just one line. For master degree, it's just one line. And it's really closely resemble your title. Like to develop, to
Purpose.
Similar to purpose, but objective is a clear goal that you want to achieve. So it's what you promise to the examiner, what you promise to when you present your when you present your proposal, right? The examiner will look at this and see whether this objective of your research. You say you want to develop a new algorithm. Is it feasible? So that's what you will face when you do your thesis proposal presentation. They will look at this, and a lot of the time, students mistake by writing down objective like 3 or 4 objectives. That's too much for master thesis. The master thesis at most just 1 or 2. And then scope would be the boundaries of what you do. Like you can mention, okay, you want to vary the temperature, you want to vary the pressure, something like that. The literature review would, I will go into this, but this is the order of how I would approach it. And as I said, the introduction is to tell the reader why. So let's assume that your examiner is the reader. When they read, they should understand clearly your motivation, right? Why does it matter? And the objective, what you achieve, what you will comment, the scope, what you will do, what you will not do, and the method, how will you do it? So when the examiner read all this, they should understand and they should be able to comment. Right? If you write, imagine if you write your scope, if you write your method, if you do something about solar cell and you write your method regarding something that is not related to your work, and the reader will read and they'll say, oh, okay, why did you mention that? I don't see you discussing anything in your thesis. Okay, introduction. So introduction is about storytelling, basically. Similar to last time, we start from the broader image, broader picture, and go down, narrow down to your. Finally, you will mention your solution, what you want to do, right? Start from a big problem to specific questions. Convince the reader why the problem really matters, right? And each of these can be just 1 or 2 sentences or more, depending on how long your introduction would be. So let's give it an example. If you discuss like thermocatalyst for, let's say, reverse gas shift reaction, we would mention something about, the global warming, the increase in methane emissions, CO2, right? And then you talk about the thermocatalyst has a potential to solve that problem through the reverse gas shift reactions, where you convert, the CO2, the hydrogen, into something useful, right? And then you would mention, okay, so if you focus on the catalyst, you would mention, okay, this catalyst, that catalyst, what are the gaps, right? You mentioned that. And then your solution, right? You develop new catalysts to solve that problem. And that's basically your introduction. So reading through your introduction to understand broadly what the field is. Okay, I'll give you 5 minutes to read through this different part of the introduction and then put a number. Right? 1, 2, 3, 4, 5, 6, 7, 8.ไปไหนไปไหนฮะอ้าวแล้วมาเช็คชื่อแล้วจะหนีมันไม่มี5 นาทีสำคัญมากไหมถ้าสำคัญมากก็ไป What is the second one? Yeah, okay, let me give you some answer, right? So, so this is an example specifically for Thailand, and what we are interested right now is to develop the new way to farm the culture, to cultivate outright without using the wet method, without flooding the rice field, because it creates methane and actually release methane is more harmful than carbon dioxide. How many times more? What is the global warming potential of methane? 30? I don't remember, but if you say so, yeah, more harmful than CO2. So the context is the rice farming is important for food security of Thailand. And then we said when rice cultivation is commonly used to promote the tilting and the suppress of wheat. So we need to flood the farm. We need to flood the land in order for the new shoot of the rice to grow up and then to kill the weeds surrounding it. So we use that wet in alternation with dry, for a very long time. Continuous flooding requires large amount of fresh water. So we talk about the fresh water usage. It's fresh water is also an important part of Thailand. We sometimes don't have enough fresh water to do this, right? And then number 4, high water use places pressure on water resource, right? And the next would be flooded soil generate methane emission. So that's a problem. And dry farming or alternate wetting and dry would reduce that water use. And dry farming may affect, let's say, yield and weed control. And then what we're gonna do is exploration of the alternative cultivation method that reduce water use while maintaining, good yield, good product. That's a story I'm trying to show you, how you're gonna tell it in your introduction. And this doesn't only apply to your thesis proposal, but apply to your main thesis and when you write paper as well. Right. So this is an example of the introduction written by my students. Right. So she worked on the cooling of the solar cell. Right. So how she would approach this would be, she mentioned first the motivation, right? The climate change driven by fossil fuel usage, and CO2 greenhouse gas emission. They put reference. And solar PV offer, good potential to meet that energy demand to replace the fossil fuel. However, the land use and end of life e-waste is a concern because lifetime is like 20 years, right? 30 years. The efficiency also decreased with increasing temperature. That's what we found in Thailand. That solar cell that normally run, on paper it said 20%, running in real life is only 60% because of the heat in Thailand. And the reason for that is that the operating temperature of the solar cell in Thailand can reach up to like 65 degrees, which reduce the VOC and other things so that the efficiency actually drops by 4%. Right? And also the degradation is faster. When we buy a solar cell, they say it lasts for 30 years, but in reality, we only use it for 25 years, and everything goes to waste. And then we said, okay, so what are the cooling solutions? So we mentioned about the existing solution like active cooling, passive cooling, their pitfall. And finally, we mentioned about our work where we developed the low cost, scalable, the coating method to cool down the solar cell. And then a little bit about, so I forgot actually the last part of the introduction. You can also mention a little bit about the impact, what you would do, what you do, how it would benefit the society. You mentioned that a little bit by putting one or two sentences. One thing I would like to point out here, and I think it's very important in the age of AI, is put everything in bullet point first. Imagine you go to your supervisors with 20 pages of AI generated content because you didn't have time to do it properly. You just put everything last minute and walk to the professors and say, read this, give a comment. I think I wouldn't have time to read that 20 pages AI generated text, right? It's better for you to do this first. Put everything in bullet, right? The topic, what you're gonna discuss, the main key message, and then put the reference in every bit, right? You have key reference. And if you come to me with this page, I would appreciate more than you come to me with 20 pages of AI generated content. Because here I know exactly what you want to say. I can add, maybe you can say something more. Or your reference is not very accurate, you can add more. But if you come with the big chunk of text, you will not get such comment. It will be mostly on, it will be very hard to comment on such a long text. So I would encourage you to do this, to put everything first. And don't start writing yet because of this IKEA effect. You know IKEA is, right? The furniture brand. Yeah. IKEA effect. Let me tell you more the IKEA effect. IKEA effect is when you go to IKEA and then you buy a table, and to ask them to assemble your table, it costs $20, and the table also costs $20. You as an engineer, you don't want to pay for that. Right? You come home, you try to put everything by yourself a whole afternoon, and then your wife or your husband come and call, hey, time for dinner. You said, oh, wait a second, I need to finish this. And then you do this, I'm done. Right? You said, I'm finally done. And then you look back and then you see the screw. Two of the screws are still missing. And then you say, fuck it, I don't care. Right? The whole world, nobody would want to buy a table from you because it's wobbly, right? You would miss the two screws. In the whole world, it's only you who will use that table. That's the IKEA effect, right? And if you spend so much time, I'm not talking about the age of AI, I'm talking about when I was first year master's student, I was spending so much time writing a paper, right? Without coming up with the bullet point first. I wrote so many things, and at that time there was no AI, so each word takes time, right? I put the whole thing, and then I really believe in my text. And then the professor said, oh, this is bullshit, shit, right? What happened? You want to defend, right? You said, oh, I spent so much time, so hard to go back and change. So again, do this first, and your supervisor will really appreciate. Okay, next is the objective of your research. It's basically mean your commitment to the research committee, to your thesis committee, what you will do, right? What you will do. If you answer what the research will achieve, translating the identified problem and gap into clear, specific, measurable outcome, right? So normally the tips is, if your title is like this, thermal management of photovoltaic panel using thermally conductive epoxy-based coating, what you would do is just to add what you would do to develop, and that's it. Right? You don't go into much detail because that one you will mention in the next part is scope. So normally master thesis, one objective, one main objective is enough, and normally resemble your title. So after the scope is after the objective is the scope. So what is the scope? Right? It's when you tell the reader what you will do and what you will not do. They often when we read the thesis proposal, we will ask, okay, so what exactly you do, what parameter you use, what is the indicator, what do you call ตัวแปรต้นตัวแปรตามหลักสังเกตได้ว่า dependent, independent variables, right? You will ask those questions, and normally those questions is answered in the scope, right? So the scope is not just what you will do, but also you can also mention what you will not do. You define your boundary. Because 2 years of research, 1 year exactly, you cannot do much. So you have to put the boundary. So then the supervisors and your reader, when they read, they know, oh, okay, you will not touch upon this part. You already part of it. So it's out of the scope, for example. So the good scope usually covers system and research boundaries, variable included and excluded. Like for example, varying temperature, varying pressure, you mentioned those. Scale and condition, you want to develop lab scale or prototype or other things. It can include keywords like this, optimization, develop new method, performance evaluation, effect of query, X and Y, so on. So that's the scope. Any questions? Who here already has the proposal plan? Already did? So who of you is the first year last week? Second? Also first, second? Next part is the literature review. Literature review is the purpose of it in a nutshell is to prepare the reader so they understand your work. You have to have that in mind. Whatever you will discuss in your thesis or in your method, you should add so that the reader will come from the different field or not exactly your field. And okay, you develop new algorithm for something, you must mention, okay, this the history of this algorithm, the why it matters, how you use it in your research. But you shouldn't go beyond or go forever to do like a whole literature review, like writing a review paper, because that's too much, right? So you have to do the same. Discuss with your supervisors of what is important to be added to your literature review, because literature review is something other people have done. So many things other people have, right? So if you pick the wrong one, if you pick something out of what you want to actually say or share, it will be a lot of work and very little benefit to the reader. So yeah, think of that and discuss with your supervisor what exactly topic you wanna include. Right, and the review, you should review these 3 things. If you put in the big picture, one is the current challenges in your field, right? So elaborate more on your motivation, why you do it, and then the existing solution. It's talk about PV cooling. We only mentioned about active cooling, passive cooling a little bit introduction, but here you have a chance to elaborate more on, okay, what are the classes of active cooling, what are the classes of passive cooling, what are the material people use, right? And since my master student, they develop new coating method, they new materials. So she has opportunity to mention here also the materials other people use, right? The way people put that cooling thing on the back of the solar cell, right? And then you mentioned the last thing is the apparatus, methodology and protocol, right? So here we'll bring everybody to the same page of like what protocol you want to use. For example, you want to calculate the solar cell efficiency. What kind of equation do we use? And there are different ways to calculate the solar cell efficiency, or the methodology of how you put things on solar cell and so on. So here are the three main things that you normally put in your literature review. But again, discuss with your supervisors of what you're going to write first. Otherwise, it will be a review paper, which is not a bad thing, but it will take up a lot of your time. And I think for the master degree, the most important thing is to do your research. When I was doing PhD, I go to my supervisor so many times and ask him, "Oh, can I write a review paper?" He always said no, because he want the original research out of the lab, not review paper and increase the citation. So on. He doesn't care, or that he care about the original idea, original research that come out of the lab. The story is a little bit different if you're a postdoc or if you want to go into academic, where you might need more of the number of citations, index, and so on. So some professor might encourage you to do that. But for master degree, I would encourage you to focus on getting the research out, doing the right, developing the right technique, the new technique, and hopefully, as I mentioned last time, the key goal is to be able to publish it. Right? Otherwise, for me personally, I would think if you come here, spend 2 years, and you don't get your work to be published, or you don't, go present, or come up with some patent, or your knowledge stick with you, that is something that I don't think is a good thing, because you're already spending 2 years. You should move the science forward a little bit, right? So one of the ways to do that is to do the knowledge dissemination while writing papers or go to the conference. So yeah, it's the same thing here. When you develop your method next part, you have to have some key idea in mind of, because you already read a lot of papers, what kind of research can be published, right? When you design your method, when you design your methodology, you know exactly how you can move toward that end goal of publication. Might be a bit abstract here, but I give you an example. When I was a master student, I didn't read too many papers, and in my mind, if I just do one experiment and get the result, and I see some kind of trend, I should be able to publish it. But turn out, a lot of the time, you need to repeat your experiment, right? You need error bar. Right? If you said this new material gives the performance of X, people expect to see the error bar. Normally, you have to do it 3 times, like triplicate. Right? But at that time, I didn't know. I planned all my experiments doing only 1 time. I see the trend and everything. But when I tried to publish, the referees, they said, "Oh, it's just a one-off thing, right? It's not reliable." I reported the data of, material producing X kilogram of hydrogen per day. But they said, "Oh, what if some people repeat exactly what you do and don't get that exact number?" Right? Normally, when we report, we should have like an error bar and say, "Okay, it's X kilogram of hydrogen plus minus, the uncertainty." Right? So this kind of thing you have to have in mind when you design your experiment, right? So that you can publish good research. So this is just an example of that same example that I showed you during the introduction part, right? The possibility of the review topic can be something like this. You can review, the conventional wet dry farming, what is wet farming, what is wet and dry alternate, the water use, the resource demand in rice cultivation. the methane emission of each method because you care about global warming. The what are the alternative? What are the gap, right? Effect of the dry farming, right? The rice yield, you can review those things. The rice yield and productivity decrease or increase. The weed dynamic, how the weed is doing when you don't flood your rice farm, right? And then the last part will be the methodology. Like, okay, if you want to implement the scientific experiment, what are the methods or what are the things that people used before? Like, if I have a two land like this, one is the reference, one is the one you do experiment, but just one set of result is not enough, so you repeat 3 times, right? And maybe you do left and right alternate, so the sun is not biased, so on. So yeah, you can mention about how you're gonna be doing the design of your experiments. Okay. Next part, what will you finish early? I think I speak way faster when. Methodology. Methodology, the key words here is to be transparent. Because methodology, when you write, eventually it will end up in your paper. And when people want to repeat, they must be able to repeat. A lot of the time, people try to hide some statements. I don't agree with that. I think we should be transparent. When people read your methodology, they should be able to get exactly what you reported. So be thorough when you write a methodology, right? For example, what material used, what apparatus, what parameter, measurement, what are the frequencies you want to measure. So it's basically a step-by-step guide so other people can repeat. The next part is the abstract. Right. Have anybody here wrote the paper before? Abstract in the context of your research proposal or thesis is a summary of what you write in the whole document. Right? Start from similar to the concept of the introduction. Start from the context, the gap, the objective, the approach, right? The method you will use, the expected outcome. So in the paper, you would mention the overall outcome. For example, you said, oh, the solar cell's temperature is reduced by X%. So that the people, when they read the paper, they know, oh, okay, this is the problem you want to solve. This is your approach. This is a method, and this is the outcome. But for the proposal, the thesis proposal, the last part, because you haven't done it, you propose it before. So the last part would be the expected outcome. What kind of outcome would be expected from this? This is an example of my own papers. So it's just a whole story putting together in 200, 300 quotes. Okay. So I start with the context. Photocatalytic water splitting converts sunlight directly into soluble hydrogen. And because of the limited space, I jump straight into the gap directly. So the gap is commonly involves pure water and land for plant installation while generating unusable wet heat. So that's the nature of this approach and the gap. And I jump into the objective here. Our approach here, we develop these new materials, new methods that utilize the whole solar spectrum. Half of it is utilized for hydrogen evolution, half of it is utilized for water evaporation to get the clean water. And this is the performance, right? The outcome, performance. And then lastly, what kind of impact it gives to the society. So yeah, it's just it's a place where you can briefly summarize everything that we do. So the example of the abstract can be something like this, but you and doing this thing nowadays in the age of AI is really easy. To similar to what I told you. So making the bullet point, discuss the thing with your supervisors, and then at the end, after you put all that bullet point to AI, you can generate really beautiful sentence for you. No repetition. A lot of the time when myself, when I write paper, back then what happened is most of the time I repeat what I already said. And sometimes the whole paper I would repeat the same thing 3 times. Right? That problem would never exist with the help of AI. So you will be able to communicate very effectively. You come up with the bullet point first, and you put in the AI. Similar to the abstract, right? You put the main sentence that you want to say, and then AI will help you connect the dots. That will create a beautiful abstract for you. Okay, and the last part is the title. So the title generally has the 3 components. One is the approach. One is the target problem that you want to solve, and then the key mechanism or key method. It might look like this: electrochemical reforming of glycerol for low energy hydrogen production by using the material to do that. Floating solar photocatalyst for decentralized fuel on open water by using hybrid device. So generally, it doesn't have to follow this pattern, but I find this is very common, and a lot of people use it. Right, and after you get the title, it's very easy to go back to objective, right? Development of electrochemical reform. So yeah, this two, title and objective, they go hand in hand. I'm giving you the example of the paper I rejected in some journal. Right? When I see this kind of title that cannot read very well, have a lot of this abbreviation like whatever method title 3, it's not very good title. So avoid this thing. Right? A lot of people will be, like ETA effect. You are in love with your research, right? You would say it's a novel method, it's a new method, never done before. Those kind of claim, like new, first ever, this shouldn't be included in abstract or in any way. It's not common to do that unless you know exactly that it's really very, very new. It shouldn't also be too broad and vague. It should be specific enough, right? If you develop a new catalyst for dry reforming, and your title is new catalyst for dry reforming to solve global warming issue. That's basically too broad, right? You should mention, okay, what exactly is your approach, right? Your system. That it's a hybrid between titanium oxide and this and that, for this method. So people, when they read, they know exactly what you do, not way too broad. This is an example of bad and good, bad titles. As I mentioned, you shouldn't mention something like this: novel, revolutionary, right? First ever. So that's not good. And bad abstract would be something like this, something also too broad. right? Rice farming is important for Thailand. Many methods have been studied in the past. In this research, rice farming will be investigated using different approach. No idea what approach that is to improve efficiency and so this kind of thing is too broad. You can see, right? You have to be a bit more specific. Or hype driven, right? You're really into your work. You said this study presented a novel and groundbreaking method for rice farming that can significantly improve productivity and sustainability. The proposed approach is innovative and has great potential to solve many agricultural problems. The results are expected to be very promising and useful for farmers. Right? It's not only hype driven but also broad. When you read, you don't know what is your proposed method. Or your system. I cannot understand. Should be specific. You get my point. So back to this page, right? You start off. This is the structure once again, and normally you would approach it this way. I would recommend start from introduction. Get your storyline straight. When it's more like abstract, but a little bit longer, right? And then you end with your approach that you will do, and then you follow by objective, right? Objective normally one, right? I'm giving you the summary again. One objective. For PhD, maybe 2 or 3 objectives. Scope of research. You mentioned what you will do, what you will not do. Literature review only the important things that would be relevant to your research. The method. Method is to convince the reader that you know what you're doing. If they read your research proposal and then they check the method, it will not get you there, right? Because the proposal is to get the comment, the initial feedback of how you're going to get there to achieve your objective. So if your method is questionable, that's not good. So you have to make sure that your method aligns with what you want to achieve. Right? And then after you write all this, you go back, you summarize everything, put it into abstract. And in title, for me, title can be after. It's like picking things from here and there, putting them together to represent your project. Okay, that's it for today. Any questions? You seem to have some questions. Yes. We still have 13 minutes. Want to go have lunch? So yeah, about my work. So when I proposed my, not so long ago, 6 years ago, I thought I proposed my work. The proposal of my work was when you do the solar utilization through the material, photo catalyst or any light software similar to silicon. It utilizes the photon to activate the electron hole pair. So you get electron and you get the hole, and electron go to do one reaction, the hole goes to do another reaction. The problem is if the light that you can use is specifically designed for that band gap of semiconducting material. So meaning that if you want to use your material for some applications, it can only absorb the light that is larger, that has more energy larger than the light gap. And everything that is below it just goes into something like this. Also, if you have the band gap very small like silicon, and you shine the light, which sometimes has more energy, it has to come down to that band in order to be used. So that also wastes a lot, and that is also generating heat. So my proposal when I applied was, can we develop the system that utilize different light for different purposes? So if the UV light, the strong light, the high energy light is good for making hydrogen, the visible light, maybe we can use it for making chemicals because it requires less energy, and then the heat part we can use it for something else. So I draw some kind of like static device, three layers device. One use like UV, one use visible, one use ion, etc. To the supervisors, Professor Irving Reisner, he likes it. So my PhD thing was combine strategy to increase the light solar utilization. Instead of using one single light, I can use the whole spectrum, and that's the paper you saw, the abstract. So UV light used for hydrogen, and then the rest of the light used for vaporizing seawater underneath to so that the photocatalyst on top can interact with only clean water, not the seawater. So we have like the two layers. The IR light vaporize the water to create the clean vapor, and then the catalyst on top split the clean vapor into hydrogen and oxygen. And then whatever left over that catalyst cannot convert, we condense them down into drinkable water. So in one device we get two products, one is hydrogen and one is clean water. And we found that by doing this, we can float this device on also other water, not just seawater, but we float it on industrial wastewater or black and turbid water because the light absorption is happening on top. So whatever dark solution we have underneath.
เทคโนโลยีอาจารย์ของพีซีที่เกี่ยวกับเชิงเอาเข้มข้นของผู้กับที่ต่างในการทำวิจัยคุณภาพต่าง
He asked what's the intensity of the PhD in July information. What's the I would say the mindset over there. I did told in the video if you watch it. So in Japan, where I did my undergrad and master degree, the professor would give me 10 papers, ask me to read, and then come up with a way to make something a little bit better. So you would read 10 solar cells paper and say, oh, okay, maybe I can change this part to make the solar cell 0.5% more. But in the UK, when I first talked to the professor, he said, I don't care about it. I want you to develop new method, new concept, new ideas. And regarding the efficiencies of the commercial viability, if the idea is good, if the paper is good, people will continue on board. So just a different way of thinking. And PhD in Cambridge or in UK in general don't require any publication. So you can graduate without publication. But no, not many people graduate without publication because the requirement for PhD is you have to create substantial body of knowledge to bring the field forward. So by that definition, if your work is not publishable, if your work is very low impact, they will not get it back to. But for most of the time, you require PhD, you require papers. And the first month or two when I arrived there, we had like a Christmas dinner. The professor he made a presentation and he showed the statistic of the number of papers that the PhD student published past slide. And I was shocked because on that graph, every PhD on average published 3 first author papers and published 4 authors papers. So in total 7 papers out of PhD. So that's the average. But at that time I was like, okay, this is the expectation. We have to meet that expectation. So yeah, the expectation is high in Cambridge for sure. But the working environment and the collaborative effort is important in terms of getting there. Those 7 papers in 5 years. 4 years. So you can graduate 3 to 4 years. But the first day I talked to my supervisor, I said, oh, I want to graduate in 3 years because I already did my master's degree. And he said, of course you can try. But normally in the department, the whole department, people graduate without that. But when I graduated, there was some guy who finished with PhD in 3.5 years. That I think that's a lot. But I took 4 years. I think the environment is also different lab by lab, right? So my experience with some lab in the US is a person pursue the idea alone in the lab, right? That's what they want you to be is they want to train you to be the independent researcher. You develop everything from start to finish. And in some lab, the paper generally have two names, student and then professor, right? But where I went to school, like in Japan and UK, that's not the case. So I appreciate that because it's like we can ask someone who know what we don't know, help that you know all the pieces coming together with your idea as a core. Work that's more collaboration and the same thing applies if you develop new method that the whole lab has to use. You need to be on every paper. That's so that's the nature of the lab that I did. But I don't say that the whole UK is like that. Or I also don't know about how it works in Chula, but at least in my lab, I try to make it more collaborative. Okay, sounds like a good time to stop. So I will see you next week and enjoy your lunch. Sigma Pro มีครับเอ๊ะเรื่องเหลืออีกกี่ครั้งนะเรียนกับอาจารย์
การทดสอบวันที่ 2มีลา
แล้วมีเรียนต่อจากนั้นอีกป่ะไม่มีใช่ไหม
แต่เขาบอกว่าเขาขออาจารย์เป็นภาพเป็นหนึ่ง
ใช่น่าจะสอนอาทิตย์หลังจาก2นั่นแหละนี่ครับ Yeah.